Hi guys, welcome to this video. This is Dr. Moorthy, working as Assistant Professor in the Department of Mechanical Engineering, SNS College of Technology, Coimbatore. This is a lecture series of engineering mechanics, and in that video we are going to discuss about a topic called a parallel axis theorem and perpendicular axis theorem in properties of surfaces and solids. So this parallel axis theorem and perpendicular axis theorem is used to find the moment of inertia in the object, and this moment of inertia is also depend on the centroid and the center of gravity. So mainly first you should know what is centroid and center of gravity. So the centroid is above for two-dimensional object or two-dimensional plane, whereas the center of gravity is for the three-dimensional solid. So that is where the entire weight of the object is assumed to be acting in the particular point. That point is called centroid or center of gravity. So first the parallel axis theorem. So this parallel axis theorem is to find the moment of inertia in the object. So the moment of inertia of an object or area about any parallel axis to its centroidal axis is equal to the sum of the moment of inertia about the centroidal axis and the product of area and the square of distance between the two axes. So it is described in the diagram where the d square is described as the distance between the reference axis and the centroidal axis. So that the square of this distance multiplied with the area of object and to adding the moment of inertia about the centroidal axis will give the moment of inertia of the of object with respect to any reference axis in the system. So the formula is I equal to Ig plus A into D square, where I the moment of inertia about any axis or any reference axis, Ig the moment of inertia about the centroidal axis, and A it is the area of section, D the distance between centroidal axis and the parallel axis or reference axis. So the application of the parallel axis theorem. So first the find the moment of inertia of the build up beams like plate grinder, T beams, I section and compound columns. So in that parallel axis theorem with the formula we can easily find the moment of inertia about any kind of section, whether the T section, I section or a different L shaped section or Z shaped section, that we can easily find the moment of inertia of the particular section or particular the compound figure. The compound figure means the combination of the multiple section combined to give the composite structure, so that we can easily find the moment of inertia by the parallel axis theorem. And the second one is the application, the design of columns and compression members. These columns and these designs and the structure is designed based on the moment of inertia, where the application of load and the rotational motion. So by considering these factors that we can design the columns width and length, we can easily find it. So see in the diagram, we can, the first diagram, see the beams and it is supported by the columns, and what is the impact and what is that is we can call it as the buffling, that we can easily find with the help of the parallel axis theorem. And the analysis of thin walled and box section. So this is the application of the parallel axis theorem that we can easily find. And the earthquake and wind load analysis, so where we can find what is the inertia force and what is the direction of inertia force, what is the impact of this inertia force, that we can find and the second, what is the deformed shape after the earthquake, what is the reaction or what is the reaction after the earthquake, and what is the direction of inertia force the based on the external force acting on the entire structure or the column. So next one is the application, another application, the ships and for marine application. The ship is moving in the ocean or sea, and we can see in the all the direction 360 direction we are facing forces or the external forces that creates the inertia force, and what is the direction, so that we can analyze or we should analyze. So then only we can find the stability, or we can make this maintain the stability of the ship or boat. Then the next one is the perpendicular axis theorem. So this perpendicular axis theorem is nothing but by adding the moment of inertia about the two mutually perpendicular axis theorem, that we can find the in the what is the moment of inertia in the on a third axis, or in the third axis direction. So for any plane, the moment of inertia about the perpendicular to the plane is equal to the sum of moment of inertia about two mutually perpendicular axis theorem. In that formula we can get the I of z, that is moment of inertia about the z axis, is equal to the moment of inertia about the horizontal axis and the vertical axis. So then what are the different applications called the moment of inertia calculation in the structural application, and the beams and column application, and then slabs and plates, and the torsional analysis of the circular members, design of structural connection and joints, and bridge applications, earthquake application, and load wind analysis application, geotechnical and foundation design applications. So these are the different applications that we can use the perpendicular axis theorem to find what is the moment of inertia and what is the impact of the structure that we can find. So thank you for watching this video.